All right, guys, I got a question from which page? Thank you.
I can tell you the problem.
Smart ass. Which page are we talking?
Are you talking about?
Yes.
Is it like 79?
Page 79? 79?
Oh, yeah.
Either way.
Nope, I lied.
You get one.
Page 80. Yeah.
Page
I
80?
got it.
Okay.
Yeah,
The suspense
page
is killing me.
80.
Number,
80 and 81 somewhere.
number what? 54.
54, yeah.
Okay. And that sort of ties into what we're talking about now, so that's really good. This is back in section 1.8, number 54. And you're seeing problems like this again. It says, is 2 a solution to 3x minus 6 equals 5x minus 10?
What does it say is 2 a solution?
Page 80, number 54.
Oh, sorry.
That's all right.
I'm good. Go ahead.
Oh, is that the one you want to look at?
Yeah. I just didn't write that on mine.
So it says, is 2 a solution to this? So how do you... Now, the last thing I want to see on this section, a lot of you guys came into this class already knowing how to do some basic solving of equations. That's really cool. That's really nice. But when they say this is a check question. Check this answer. So how do you check that answer? Plug it in. It's a lot like that a plus by, and I tell you a is 5 and b is negative 2. Just plug the values in. In this case, when you plug it in, the way you tell if it's an answer is if what you end up with a true statement. So when you plug a 2 in, you get 3 times 2 equals 5 times 2 minus 10. So what's... Sorry.
Oh, sorry. Go ahead. I found it. Go ahead.
So when you get on this side, what do you have to do first here? Beautiful. Multiply before subtract, so you get 6 minus 6 equals 10 minus 10. 0 equals 0. Is that a true statement?
Yes.
Good. That is definitely true. Does that mean the answer is 0?
No.
Hell no. What? The fact that that's a true statement tells me that 2 is the answer. When you plug 2 in, it made it true. That's really what solving an equation does. You find the value that will make that equation true. This 0 has nothing to do with the answer. It just is telling you, yeah, 0 equals 0. So then that's the solution. 2 is the number that makes both of these sides equal. So yes, 2 is the solution. Sweet. Is that cool? Yeah.
Why is it equal 0?
So you tell me, when you plug a 2 in, right? Because they're asking me to check out 2. So when you plug a 2 in, 3 times 2 is
6,
minus 6 is...
1,
No, what's 6 minus 6?
0.
Yeah, if you got 6 or something and you take 6 away, you got nothing left.
That's still 1. 6 times 6 is
No, 6 minus 6.
0.
If you had $6 and I took $6 away from you, how much money you got left?
0.
Yeah. And if you had $10 and I took $10 away from you.
0.
Good. And 0 does equal 0, right? So that is a solution. Can somebody tell me what that would look like possibly if it was not a solution?
7 equals 0.
I love it. 7 equals 0. 2 equals 5. Negative 1 equals 18 billion. Right? Just something that's not true. That would tell you that whatever number you plugged in is not a solution. You guys with me so far?
Yes.
So basically, when you see a problem, there's one way to think about it is, I'm trying to figure out, when I try to solve this, I'm trying to find the number that I can plug in for x to make this statement true. This is a mathematical sentence, right? That says this side equals that side. So I want to find the value that'll make that true. And 2 does make it true, so 2 is the solution. Yes,
So
sir?
how do you know that was multiplication when that 3 and that 2 is like that?
Because of the fact that these are
They're kissing.
next to each other. Or kissing, whatever will make you get through it, right?
They multiply.
Alright. I don't know what you see up in the sky when you look at clouds. I don't want to know.
No, it's just that a tutor at the place explained it to me.
Really?
Yeah.
I kind of like it, you know the way I do this. There's no other symbol in the middle. There's not a plus sign, there's not a minus sign, there's not a divided sign, so it must be multiplication. It's the last thing left. And we definitely don't mean if x is 2, this becomes 32. That's not what that means, right? This is the way that we represent multiplication between a number and a letter. We represent it by letting them kiss. Aw. Yes?
Number 41. 7 times 7. X plus 2y equals 3x.
Well, it doesn't equal it. That one says...
Equals
Oh, yeah.
3x.
So it doesn't. There's no equal sign in there, right?
With that like big line, maybe.
That means divided by. So this is number 41 on that same page. Now, if you saw that sitting there, if you look at the top of the page 80, and you see that problem sitting there, what should you do? What do you do with that problem? It doesn't. What are the directions?
21, 6.
I can't do anything because I don't know what x is. I don't know what y is.
X is 2.
How do you know that?
It says either.
I love it. So you switch the page back and you look for the instructions, and it says evaluate each if x is 2, y is 5, and z is something I almost don't care because z doesn't even show up. Z is 3. See what I'm saying, right? So the page before, the page before they tell you these are true. X is 2, yeah. So then you can plug those in and figure out what it is. So what's the difference between number 41 and number 54? Both problems you're plugging stuff in. But are they the same problem?
41 you're solving, is the other one you just find out if it's true or not.
Yeah, 54 you're plugging in to see if an equation is true. 41 you're just trying to find the value of that. Right? This is not an equation. No equal sign, not an equation. Right, so there's no answer to this. It represents a number once I plug in values for each of these. This is an equation. There's maybe a limited number of things that'll make it true. That's the difference between those two. Over there I can make x, y, and z whatever the hell I want to. Here there's only certain values of x that might make this true. You guys with me? This is a little more restrictive. It says this has to equal that. Over there it's just this. It doesn't have to do anything. It's just there. You guys semi with me. This is what we call an expression. And this is what we call an equation.
So
Alright,
an
how we doing?
expression doesn't put any place value on variables.
An expression does not have an equal sign.
You have to solve it.
There's no solving that you do. There's actually just evaluating. I can plug stuff in for that and see what number it becomes, but I can't solve it. Solving means I can get x by itself and figure out what the value is. That's what solving is.
I mean, like, we can find a solution for that.
No, there's no solution for that. This expression has a value
Yeah.
depending on what x and y are,
Yeah.
but I can't solve it. The only kind of things I can solve are equations. Cool. Okay, so this is all basically terminology. I don't want you to worry too much about terminology. I want you to worry more about process. Can you do these things?
Yeah, but if you don't know the term, you can't do the process.
True. But right now, what's most important is process. You'll pick the terms up as we do more and more of these things. Yeah.
On exercise 2.3, like question 75.
Question. I'm sorry. Which ones?
2.3 exercise on 75.
75.
It says like find the difference in evaluation elevation between the two lowest elevation shown.
I like this. So find the difference in elevation between the two lowest elevations. So the two lowest elevations. So if I, real quick, if I just said find the difference in age between a 28-year-old and a 30-year-old, would any of you say -2? Would that make any damn sense? So when I say find the difference between these two things, these two people's ages, if they're 2 years apart, you're going to say 2. So when they say find the difference between the two lowest elevations, you're going to take the bigger one minus the smaller one always. So what's the two lowest elevations? This is page 118.
282.
So it's -505.
Yeah, you got to be careful. What's lower, -505 or -282?
-280+2.
Yeah, why is that lower? Because it's more negative. Right? And going lower and lower and lower. So the more lower means more negative, more below sea level. You guys with me? So if I got the two lowest are -505
Negative
That's the highest.
minus should be
and
5.
-436. I like it. So those are the two lowest elevations. Which number is bigger?
436.
Oh,
Which number is bigger?
505, like, negative.
You were right. This number is bigger. Why is that number bigger?
It's closer to 0.
Be careful when you say that, because 1 is closer to 0 than 8. But 8's bigger than 1. So what you really mean is that one is to the right.
It's less negative than
Less negative than the other one. Right? If I had to owe money, this much money or that much money, they both suck, but I would choose this one if I could. Right? I'd owe less money. This is a better place to be. So if I want to find the difference between these two, I take the bigger dude minus the smaller dude. And of course, what do you do there? What? Yeah, the first thing you do, if you don't, you can always do just two numbers when you're adding, subtracting. I don't have something plus something or something minus something. I have something minus negative something. So what can I do with this? How can I consolidate that? Plus, I love it. So make that second nature. When you see minus and negative, you can automatically make that this plus that. And how the hell do I do that? Yes, sir.
The 505 plus 436 equals 1, that's 4, and that's 9, 900 and...
So be careful. Be careful. This isn't positive 436. This is negative 436. So this does not say 436 plus 505. It says negative 436 plus 505. So are they the same sign?
No.
So what do you do when they're different signs?
Minus.
So 1 is going to be 15.
Subtract.
Subtract. When they're different signs, you subtract. And how do you subtract this? He needs something, he ain't got nothing, so I gotta steal from this dude, right? Make him 10, and now I can do what? Make him 9 and give 1 to this dude.
9.
Good. So we get 9, 6, and that's it.
Teacher, my question was, like when we find like this one, like find the difference, so we put the biggest one at the beginning, subtract it from the other one. Because like I have another one on like 64, same thing. It says like find the difference in temperature between the...
Yes, good. I love it.
So we put the biggest one.
Big minus small. Yeah.
Can't you just subtract and get the same thing?
You have to be careful about... How do you mean just subtracting it? Yeah.
Just take
The
the
more
zeros
you
off.
understand how numbers work, the more you can realize these are both negative. So you can just subtract 505 minus 436 to see the difference. But you have to understand more about how numbers work. You with me? So I am always going to show you the full way to look at a problem. The more comfortable you get with the problem, the more shortcuts you can take. Hell yes. If you try to learn shortcuts, you're not going to really understand when to apply them. Right? Very often teachers teach a lot of shortcuts, but then students are like, okay, when do I do that? When? So if you see a shortcut, I love it. Beautiful. If it came up with the same answer every time, you got it. Sweet. The shortcut works.
But if it's 69 is just the difference,
Yes.
wouldn't it still be below 0?
No. When I say the difference, if I plot these on a number line, if I put it like this, what's this going to be? Which one of these numbers would this be?
The 436.
Yeah, 436, because that one's closer to 0, like you said. And of course that one's going to be the, obviously my scale sucks, but I don't want to put 0 way down there, so just go with it. So the question really says, what's the difference, put the whole number, what's the difference between those two? And it's really just saying how far apart are these two? Right? I really don't want to go all this route, but distance is absolute value. That's why the answer is going to always be positive. If I just say how far apart are two things, that number is going to be positive. How are we doing? You guys all right? Especially when I'm talking about physical quantities. How different in elevation are these two things? Okay. All right. So anything else from stuff here before we get back into 2, 6, and 3? Yeah.
Page 119, 92, 51 times 89.
Okay.
Do you put 9 and then 40, you put 0, put 8 and 40? Because
Then you first do the 9, right?
it's 9 and 40,
What's 9 times 5?
45.
Good.
And then 0,
Good.
8 and 40.
Good. And then you just add together.
It's 9, 13, 5 and 40.
Yes, so 9, 3, 5, 4. Okay.
Then
Well, we're not, that's how all of those work. They all work the exact same way.
they do?
Yep, they all work the exact same way. They're going to have different numbers, but multiplication like this always works the same way. So it sounds like you got the pattern down. Don't treat each problem like it's brand new. Every problem, you make up any numbers you want to. 614 times 78, I basically do exactly what you just did here. Right? You do 8 times 4, 8 times 1, 8 times 6, then 0, 7 times 4. I mean, it's the same pattern. Right?
But I don't know how to do that long division.
We're not dividing it, that's just multiplication.
That's not like.
Yep.
Wait,
But I think you know it better than you do when you think. You know it better than you think. But come see me after class. We can talk more about that. Okay. So here's the thing I wanted you to get from what you did last time. And I understand that if the hard part is to learn something new, and this might be new for some of us, or it might be a long time ago that we learned it, you have to start off pretty easy. And if you start off pretty easy, there are often other ways to do something. So I know that if I write 7x equals 42, most of you should just be able to say what the answer is. But what you're trying to get practice with on this easier problem,
We divide by 7.
hey, no text, put that on. So what we're trying to get practice on with an easier problem is the steps we got to take. Because I want to know really, really how to do this all the way out. Not just to be able to see it. It's awesome if you can just see it. But you need to get practice with an easy problem, the steps you got to take. Because when we get to this point, right? I'm not going to chill. When I get to that point, if I don't know the steps I need to take, can anybody just look at that? I want to see if anybody is Rain Man out there.
And minus 14.
I love it. That's right. No. In fact, we'll keep that up there. We'll solve that later. Something to look forward to.
Yeah, like next semester maybe.
No. This is exactly a problem you might see on the next test.
You know, actually, I was having trouble like on 145, number 36, x over -9 equals -9. Those fractions. I don't know if we can talk about that.
Where are we at?
On page 145.
Oh yeah, we'll do that one next.
We can work on that next.
Yeah, so we're still doing this one.
Okay.
Divided by 7?
I love it. So, the basic idea of the equations. And this is why I kind of made it the way I did on that handout. If you start, and this is not the way the real world works, but this is the way to learn how to solve equations. In the real world, equations come from like modeling the weather. So when you find the weather forecast, they've got computers doing this because the equations that model weather are disgusting. So we have computers, why the hell not put them to use? But humans have to actually figure out what goes into the equations, right? The density of the air, how cold it is, what the temperature of the water is, and all this kind of stuff. And they throw all that into the equations, and they see what the computer says. You guys kind of with me? So an equation, a very basic equation could be, what's my profit function? So if I graph my profit, where do I want to be? Obviously there. But if you don't know the equation that governs that, there's no way to kind of forecast what you should try to do. So there's people called financial analysts that make tons of money. Why do they make tons of money? Because they're the people that say, set the price at this because the market demand is this and the supply is this and this is what's going on. You know, that they actually know the equations that tell them what to set the price at. So they can get closer and closer to their maximum profit. Are you guys kind of? There's a couple places.
Like stock?
Stock people, you got people trying to make equations. Now the trouble with stock is you try to make an equation, and they're like, oh, there's my equation, the next day it's that. So the stock market, you always have, there's one thing that works pretty well in the stock market. It's actually based, neither. If you're at all interested, it's called, if you search for Fibonacci,
Is
this
this a guy?
Italian dude, huh?
Is this a guy?
This is a dude, yeah. Fibonacci sequence, this is way beyond us, but just because this is neat. I mean, mathematics is a lot. That's right. I like that. It's some old 30s radio show or something. The Phantom knows. All right. So Fibonacci actually is he came up with some stuff that actually is applied to the stock market. But if you try to create an equation that tells you what a stock is going to do, you're going to fail almost no matter what. Because you can't really do that well. Now you could make an equation that tells you what a stock might do, and you feed into it how popular is this company and what's the demand for their stuff.
That movie, Limitless.
Second, Limitless. I love that movie. I'm like, please give me that pill. I need that. All right. So all that's on the side. I just want to give you an idea of why solving equations is so stupid important. Because equations are really what govern almost every damn thing we do. Somewhere there's an equation involved, if not millions of equations, in creating a smartphone, in your software, and whatever. Yeah.
Okay, what's the point mean? The minus 9.7.
That would be multiplication. But ask me later. You got to focus on this. Right, so focus on this and ask me that later. So I heard somebody tell me what to do here. Yeah. So in the real world, an equation comes from a situation I'm in. On that paper, what I did was I started with a value and I started doing stuff to it. So if I had x equals 2, if I multiply both sides by 3, what do I get over here? 6. If I add 1 to both sides, what do I get over there? 7. So somehow, if I solve this equation, I should get x equals 2. I'm trying to uncover what the value of x was. So one way I look at this is somebody's piled all this shit on top of the x. I'm just trying to uncover it. So here, this is not a big pile of shit. It's one little tiny thing dropped on it. Right? But how do I undo? I'm always thinking about how do I undo what's being done. The x is not by itself because that 7's there. So like you said, right now it's multiplication. So how do I kill it? Divide. So if I divide both sides by 7, pop. There's that pop. 42 divided by 7, 6, 11. And if you check it, 7 times 6 is 42. Check. So I know for several of you, you're going to hate that I will take points off if you just put 6 and I don't see where it came from. And the reason is, a lot of you guys are able to do that, but you're not able to show yourself what you're doing. And if you do that, you're going to die on things not even this hard. This looks pretty disgusting. But it won't take too much to me to put on that top of there that those of you who are able to do a lot of this in your head, you're going to be lost very quickly. And it's not because you're poor at math or whatever. It's just because there's too much to keep in your head. You got to be able to show yourself what the hell you're doing. Okay, how are we doing so far? Okay. Dude. So somebody else was, what was the problem you're talking about? X over...
X over -9 equals -9.
I like it. Okay. So you can always attack an equation the same way. We have very basic equations. The reason I call these basic equations is because they only take one step to be done. There's really only one thing being done to the x. You with me? This is not a basic equation. How much is being done to the x? A lot. So it's not a basic equation. It's a little more advanced. This is a basic one, but I still need to see the steps. Why is x not by itself? Why is x not all by itself? Beautiful. Because I know my goal is to get there. Careful. And this is the trouble we get into when we don't show ourselves what we're doing. I'll get answers like 1. But it's not right. What do you have to do to cancel that negative 9? Beautiful. Because what's the opposite of divide? Multiply. I love it. So if I multiply both sides by negative 9, these cancel, right? Oh.
So are you putting that negative 9 next to the x, or you're just
You're right, right.
there to get rid of the other negative 9?
You know how it works? I don't either. You got all kinds of stuff on there.
Did you have that fall on the ground?
Oh, is that your alarm?
Hey, Randy,
The volume on.
your alarm's on.
Okay.
Sorry, guys.
That's all right. Let's try to get back to this. So we had a division by negative 9. So to undo that, I multiply by that. I multiply by negative 9. So this side it dies. Over here, what do I get? Negative 9 times negative 9? 81. So the person that said 1, I'm not picking on you, but your brain said, I see division. Negative 9 divided by negative 9 is 1. But I see division, but I have to multiply to undo it. Right? You guys kind of with me? If I were to check this answer, how would I do it?
81 divided by
81.
Yeah, 81 divided by negative 9 is negative 9. Check. Right, so that's what I mean when I say check. Yes, sir.
Not 9 times 9 is 81.
To check this equation, what does the equation look like in the first place? It looked like this. That's what it looked like in the first place, right? That was the equation that was given to me. So to check the equation, I plug this answer back in.
So 81 times 9
81 divided by negative 9.
is 1.
What's 81 divided by 9?
1.
What do I multiply 9 by to get 81?
9.
Good. And the negative is still there, so that's why it was negative 9. Cool. All right, how are we doing so far?
And that cancels out, which is why 81 is closed.
The negatives cancel. Exactly. These negatives here
Right.
multiply to be positive. I love it. Okay? So, in order to... Well, let me do one more type here.
Can you do all fractions? Both sides?
Say again?
Fractions on both sides of the...
Not yet. What's going to happen this semester is we're going to talk about fractions, and then the last section in that chapter will have equations with fractions. Then we're going to talk about decimals, and the last section will have equations with decimals.
That's not an equation?
That is an equation. I would say it's not necessarily a fraction, it's something being divided. So I can multiply, right? Now, when I start having fractions all over an equation, I've got to think about it a little bit differently. That I wouldn't really call a true fraction. It's just my variables being divided, so I multiply. I didn't have to think of it as a fraction at all. You guys with me? Yeah.
So the big one, do you add the big one or the 11? Like 5 flat 11. So it's like somebody told me add the big one first, but the big one. Let me show you.
Maybe in a minute. Hold on. Let me try this one here. So here, the same idea. You attack it the same way. You say, why is the x not by itself? Why is the x not by itself?
Subtract by.
Yeah, it's being subtracted by 11. So how do I undo that?
Add 11.
Add 11. And I really want to stress this. And it's a little hard when the equations are just one step. But especially when you start getting multiple step equations, those of you who don't write the whole thing out, you're going to get kind of lost. And some of you guys already got a little lost on this. I saw a lot of people just putting 7 down, or -7. Where did somebody get that from? Where would you get -7 from?
4 from 11.
Yeah, -11 plus 4 would be -7, but how the hell did that happen? You're not showing yourself what you're trying to do. So here, to get the x by itself, I have to add 11. Now the reason, real quick, the reason I'm allowed to do that is if I have something equals something, how do I keep it true? If I have a weight, a balance thing, and it's balanced, if I put 11 pounds here, I better put 11 pounds on the other side, or else it won't be true anymore, it won't be balanced. So whatever I do to one side, I have to do the other side in order to keep that balance, in order to keep it true. So if I add 11 to both sides, this goes away. I get x by itself equals 15.
So then you have 15 and -11 goes back to 4.
Good. So to check it, you plug 15 in here, and that's true. 15 minus 11 is 4. So checking these one-step problems should be really quick. You should just, once you plug the number in, you should see it.
Where did you get the 11 to plug it in?
Yeah, thank you.
Here's the equation. There's an 11 there. Right?
There's an 11.
Good. So when I got the answer to be 15. Right? Unless you did you ask that question?
I did. I
Okay.
see how you got it. But where did it come from? Why did you just snatch the 11? Why did you...
Thank
you know what I mean?
No, wait. Let me make sure I understand what you mean. Do you mean this step, or do you mean just the equation that...
The second 11 you write down, how can you just come up with 11 just out of nowhere? That's my problem too, is you like just making up magic numbers?
Alright. Let me ask you this. If, let me try this. You ready? You got a seesaw, right?
Yeah.
Seesaw? And this is like a giant freaking seesaw. This is one of those awesome like Discovery shows making giant things. Huge freaking seesaw. And I got 58 people there, 58 people there, and they're all equally weighted. So it's nice and even. If I add 2 people over here, they're all the same weight, right? They're all clones. They're a bunch of freaking stormtroopers. Where's my nerds? No? Okay, that's great. So if I add 2 more people there, I better do what? Or else my seesaw is going to go crazy. It's huge, so I'm going to... Ah!
So you have to add 2 more.
I have to add 2 over there. Now, where did I get the 2 from? I love it. Wherever the hell I wanted to. Shit. I'm just saying, if I do anything to this side, for any reason, I better do it to that side also. Now, let's bring it back to this. This is not out of nowhere. I know what my goal is. What's my goal for any equation? My goal. When do I know I'm done?
You have x by itself.
When you have x by itself. So I don't just get a number out of nowhere. I say, what number specifically do I want to use so that x will be by itself? And I say, why is x not by itself?
It has -11.
Because I'm subtracting 11 from it, right? That's what that says. So how do I undo that subtraction of 11?
So what are you trying to do? Get that 11 back to 0?
Exactly. Make it go away. Cancel it. You're trying to cancel it.
Okay, so I get that part. I've had 4 different people tell me this. So I put a positive, another 11 down there.
And again, the seesaw. You add 11 people to this side.
Yeah, okay, so then I do it to the other side. It's the other side of the equator, the other side of the equator, whatever you want to call it.
The equator, I like it. That's all
I've
right.
been on a lot of tutors.
No.
Yeah, the other side of the equator, whatever. Then you got the 11, you transfer there. What I don't get, which he might not be getting, is how can you just throw numbers around like that from nowhere?
I'm not. Let me ask you this.
It just seems like...
Let's forget about math for a second. I'm going to come back to
I have
this.
nightmares about
Don't
this.
forget too much. Now listen. Can you tell me what number would I subtract 2 from to get 8?
Yeah, 6.
No, come on.
Subtract what?
Stop. What number
10.
would I subtract 2 from to get 8?
10.
What did you actually just do? How did you get 10?
I just added to it.
You added it, exactly. So if I had, what number do I subtract 2 from to get 8? Now, I was saying it wasn't mathematical. It's just a purely logic problem. Somebody took 2 away and there's 8 now. How many were there before? There must have been freaking 10. What did you do automatically? Without thinking math, without thinking X, without thinking algebra, you added 2. Just to undo, to go back in time. Put the 2 back, right? So I had something, somebody took 2 away, and now I have 8. So what did I have before? Well, add the 2 back to see that I have 10. Why am I allowed to do this? Because as long as I do the same thing to both sides, the equation is still true. So what I really want you to understand is this. Does that kind of make sense in its way? Hold on. What I really want you to understand is if I have this equation, if I really felt like it, I could add 7.
How would it make sense?
I don't care. I could if I wanted to, right? Just what the hell? Somebody came up with freaking x minus 2 is 8. I can add freaking 7 to both sides. What do I get if I do that?
X plus 5.
Good. Negative 2 plus 7 is 5. Equals, so x plus 5 equals 15. Now, what do we know the answer is? 10. What's 10 plus 5? So as long as you do the same thing to both sides, the result is still true.
That's crazy.
You guys kind of with me? No, well, now I love it up here. I love it. Somebody looked at me like, you're off your meds, Jeff? Why the hell would you add 7? That doesn't get you anywhere. Bam, you put those 2 things together. I can add or subtract or multiply or divide both sides by anything, except 0. I can't divide by 0 ever. But I can do whatever the hell I want, as long as I do it to both sides. But what will I do? The smart freaking thing, whatever gets x by itself. Because I could do anything. I could do this. What good did that do? Now I have a new equation. But how would I solve this equation?
Subtract 5.
Yeah. Why is x done by itself? Because it's added by 5. So what would I do to kill the plus 5?
Subtract 5.
Minus 5. And not surprisingly, I get x equals 10. Because no matter what I do, it's still fundamentally the same equation. As long as you do the same thing. So I'm not just going to pick a number out of nowhere. I'm going to pick the number that will actually get me back to just x. Make whatever's with this 0. Kill it. How are we doing? A little bit better? A little bit better is pretty damn good. Yeah.
Like what I learned before, like I can move it to the other side and I switch the sign for it. But like in your way, like it should be like when we add number to the whole thing, like it will be like x plus 7 negative 2 plus like say 7 and for everyone. And this one,
I'm not sure what you mean. So this is really the same thing you just said.
I know, like when I switch it, it's the same one. But like in your way, when you add the number, you should add it to the whole thing. Why you like don't add it to x?
I got you. So what is 3 plus 5 plus 5?
13.
Why didn't you add 3 to 5 and 5? Why did you only add 3 to... All you did was 3 plus 5 is 8. Why didn't you add 3 to that 5 too? Because there's only one freaking 3, right?
Okay.
So when I add 11, if I have this, and I add 11 to this side, there's only one 11. I can't add it to the x and to the negative 11, right?
But you enter it to the whole thing.
I added 11 to this side.
Why you don't add it to the other side?
I got to add it to the other side, yeah, sure.
No, to the x.
That's not the other side. What breaks an equation up into two sides? The equal sign breaks it up into two sides. If I add 11 here, now this is my scale, right? This is I can't draw freaking. This is my seesaw. Right? If this is the middle, let me put the right there. If this is the middle, what did I do to this side? I added 11. What did I do to this side? I added 22. So that's not fair. I can't put 11 people there and 22 people there. Ah, we're all dead. Right? All those tests are on your hands. Sorry. So, that's a good question. That's why. And now, this kind of leads us into what we have to study before we can do more advanced problems. And actually, you've just pointed out we actually need to study it a little bit before we can really understand what's going on here. I can't add 11 to x. I can't. What's x plus 11? Pineapple. I don't know, right? And actually some of you guys are like, yeah, that's my whole problem with math. What the hell? But I want you to understand, I can only add things that are what's known as like terms. So can somebody tell me, if I write 3x, now I know that means 3 times x, but can somebody come up with a different explanation for what that represents?
3 times 1.
I don't know what x is, so I can't say it's something specific.
Right?
So let me ask you this. If I said I see 3 cars, that means I see 1 car, and another car, and another car. So if I see 3 x's, I see 1 x, and another x, and another x.
Right?
So really, that coefficient is a way of consolidating a bunch of x's in a row. Let me see if you guys are with me. Somebody got this written down somewhere so I can erase it? We will solve it later. You got it written down? All right, I can ask you for it.
Minus 3 before, right there.
Yeah, negative 3. Yeah, let's try to be a 6. Okay. Don't worry. We got some people in. So what would y plus y plus y plus y, what would that be?
Why?
4y, I love it. Not y to the 4th power, because a power means you're multiplying. I'm not multiplying here, I'm adding. Yes, sir.
Not y by 8?
There's no 8 anything. How many y's are there?
4?
4. So that's why there's 4 y's. So this is really just an expression that we came up with back in history so that we didn't have to write a bunch of y's out. So when you see 80m, thank God we have that instead of writing m plus m plus m plus m plus m plus m plus m, right? You kind of with me? Because what would that mean? M plus m, how many m's? 80 of them, shit. So let me ask you this. Let's go back to something interesting. If I had three sheep, and I subtract
That does count as
1 sheep, let's say subtract a sheep.
2 sheep.
I love it. Now go with me. Some of you guys are like, I know in that second evidence that he's off his meds. What the hell? I don't know what meds he takes. But what I get is people do effectively this. People will tell me the answer is 3.
No.
And I'll show you why in a minute. That makes no physical sense, of course, right? 3 sheep minus a sheep is 2 freaking sheep,
Yeah.
right? I love you guys. So what does that look like mathematically? It would look like this. 3x minus x. What's that then? 2x. I love it, not 3. Do you see why somebody might say 3? What are they focusing on? They're focusing on the x canceling somehow.
All the removing the.
But what operation is this?
Multiplication.
So the only way to make the x cancel is by dividing. But this says I have 3 x's. If I take 1 away, I have 2 x's. Yes, sir.
So wait, so the x, so the thing, so like y equals 4 y's, right?
Yeah.
Because
Because
that's
you're just
4 y's.
consolidating how many y's you've got.
Because that's not 2x and it's 2x.
So another way to look at this is x plus x plus x. So if I subtract an x,
But yeah,
I have x plus x, or 2x. Right? That's another way to look at it. But please, dear God, don't do 80x and write 80x's out. I always get one person that does something like that. Like, no, turns their paper over. Don't do that to yourself or me. So what this is really getting down to, we have to go to this next step. It's like terms. So what like terms is, let me just give you the straight out definition. Like terms are, and actually let's start off with this. What the hell is a term? Let's start off with that. So if I have an expression like this, can somebody tell me how many terms there are? There's 2 terms. So terms are officially the things that are divided by plus and minus signs. So there's 2 terms here. This one and this one. Bless you. How many terms?
Terms terms are the things that are plus and what? 3 terms?
Terms are separated by pluses and minuses. So how many terms are here?
3.
I love it. 3. Right? There's a term here, a term there, a term there. 3 terms. How are we doing so far? See?
Good.
So this is the kind of thing that I sometimes might fly by without stopping for a second, because I use terms all the damn time. But I got to remember, I need to define it for you, because it's not an automatic thing. We're not born with this knowledge. That's what terms are. They're how many pieces there are to my expression, and the pieces are separated by plus and minus signs. So there will be 3 terms. Yes, sir.
Multiplication wouldn't divide it?
No.
No, only plus and minus?
Because let me ask you this real quick. 4 times 2 plus 7 times 3. I'm adding how many numbers?
8.
2.
2 numbers. I just don't know what they are yet.
Right.
That's what terms really gets at. This is a term. This is something I don't know yet, but I'm adding 2 things I don't know yet. What am I doing? I'm adding 2 things I don't know. I'm subtracting and adding 3 things I don't know yet. So it just keeps track of how many pieces I've got that I don't know.
So with that 3AB minus blah 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 plus blah blah blah, if that was 3 times the 4 times the 6, that would be 3 terms. That's Let's
No.
replace that minus sign and that plus sign with a multiplication sign.
No. Here's the reason. If I just look at 3AB
Times.
No. Just stop there. Because your point here would be like, why is this not 3 terms?
No, I understand that the right above it where you got number 2 at, I understand that 3 terms. I was just wondering if you replace that minus sign and that plus sign with a multiplication sign.
Like that?
Yeah.
So then you get 12 times 6 is 72, A, B, X, Y, Z, W squared. If you just multiply it all out, you get one big ass term.
Okay.
Right? Because you can actually multiply those out. You can get one string of a something. You with me?
Well, but you would technically do that 3 separate things if you were to write it out for you. You do each parentheses each time, and that'd be 3. And
So, the parts of a multiplication problem are called factors. I don't know if you guys remember, like, you start with 18, you make it 2 times 9, you make 9 3 times 3, that's prime factorization. The factor tree, I don't know if you guys remember doing that, we'll do some of that later. But the parts of a multiplication problem are called factors, and that'll become important when we get to factoring. The parts of a subtraction addition problem are called terms. It's really just a name that we give.
Alright, so in number 3, how many terms you have? 1?
There's only one term in number 3. Because how many plus and minus signs do you see?
Just multiplication.
Good. And I mean specifically add or subtract. That would still be one big term. It's not something minus something plus something. It's a negative something. So it's one term. Yes, sir.
So, is 72 minus or AB X 4 72?
Oh yeah, this is y. Yeah. And that's just me multiplying all this stuff out. A, B times X, Y, Z times W squared. That's how you write it when you multiply it out. You just put them all next to each other. It's a little bit ahead of us, but I want to show the example.
So a like term is...
Good. We're getting there. We haven't talked about the like part yet. This is just the terms. This is what the word term means. How are we doing so far?
Good.
Now let's talk about what like terms are. These are the things you can actually combine. So hopefully, if I put this down, let me see.
Is this adding and subtracting stuff? Only for adding and subtracting? Like term?
Terms by themselves implies the parts that are being added and subtracted. You could do anything to them, right?
Well, you were saying...
Like I could double this whole thing. We could talk about that later, but so terms by itself implies there's things separated by pluses and minuses.
Right.
Good. But I could do other operations to it. So it's
Right,
not
but-
just...
But I'm saying, does like term follow that same rule?
Well, no, here's the thing. Like terms tells me the types of terms I can combine. So if I had 4x plus x, let's just stick right there. 4x plus x.
2 terms.
I like it. Okay, now I understand what you mean. There are 2 terms. But let's go past that. Can I combine these? What does 4x really mean? Don't tell me 4 times x. 4x means 4x is added. And what am I doing? Adding one more freaking x. So how many x's do I have? 5. Beautiful. That's almost too easy to believe. That's all I'm doing. This represents 4 x's being added. So if I add one more, I've got 5x. So it's really 4x plus understood 1x, right? Anytime you see an x by itself, there's an understood 1 there. I got 1x. Math people, we don't like to waste time, or we're lazy, however you want to look at it. We're going to write that 1. So what about this here? Where's your like terms? Which ones are like terms?
3y
Yeah.
plus 2x.
Those two are like terms, right? I can definitely not put 6y and 2x together. And what I always get, I'll get somebody to say, okay, this is 6y minus 3y is 3y. And then I'll have them tell me this. Now real quick, I want you to understand. Don't write it down. This is a mistake. This is not right. But can you see where that came from? They just slapped everything together, right? Now, what my little note would say on this would be, I don't see any xy's. I do not see any xy's up here. I see some y's, and I see some x's. I don't know where you see 5 xy's at. I don't see any xy's. So what do I mean by that? Some of you guys are like, whatever you don't see, Jeff, I don't care. But if I had this problem instead, which ones are the like terms? Are any of these like terms?
All 3 of them.
All 3 of them are like terms. They all have, here's the definition of like terms then. They have to have the same variables and the same amount of each variable. So in that case, they all have x's and y's, and they each have 1 x and 1 y. So they have to have the same variables. I'm slowing my speech down. This is probably a note. Have the same variables and the same amount of each variable. If you can read that, you're pretty good. They have the same variables and the same amount of each variable. Now, what would the answer here be? 6xy minus 3xy is beautiful. 3xy. 6 is something minus 3 is something is 3 of that thing. You with me? So it's 3xy plus 2xy, 5xy. Kick ass.
How would be 5?
Let me ask you this. If I had 6 shoes, and I took away 3 shoes,
3.
and then I added 2 shoes, how many shoes you got?
3 shoes. 5 shoes.
5 shoes. So I got 6 somethings minus 3, that same thing, plus 2 of those same things. I got 5 of those things. Just because I said shoes here and XY's here, it's the same idea. I'm just consolidating how much stuff I got.
It's like x, 3, and y, 3.
3 of these plus 2 of these is 5 of these. Yes, sir.
Okay, back to the 5xy. Then 3y plus 2x. Then what would be, is there an answer for that?
No, this is it.
Don't leave me hanging.
You're done.
That's it?
You're done. So the mistake there was somebody went too far.
Okay.
They thought there was more like terms. The only like terms in this problem were these two. Once you put them together, you're done.
Okay.
I love it. So that's another thing about math. You sometimes are like, when do I stop? And people try to force it to go further than it should. It's actually almost better to not go far enough in a way. I don't want to. It's better to do it right, but don't force something past the point. You don't have to keep going to get one thing. That's not the way it's going to work. So what do you think about this here? How many terms are there first?
2.
There are 4 terms. Right? And 8x plus the 2x squared minus the 4x squared plus the 6. There are 4 terms up there. You with me? There are 3 plus and minus signs, so they must be separating 4 terms. So remember, terms are always the parts that are separated by pluses and minuses. So it's this chunk plus that chunk minus that chunk plus that. So there's 4 pieces that I'm adding, subtracting. Now, which ones are like terms?
Plus 12.
Negative.
The two middle ones.
The two middle ones.
And the two in.
I like it. Now careful. I like these 2. Why isn't that one also like with these?
Because it's not squared.
How many x's does this guy have? 1 x in there. Like 8 times 1 x. This is 2 x's in that one. That's what I mean by that definition. The same variables. Okay, they all have x's. The same amount of each variable. These are the only 2 that have 2 x's. How many x's does he have? So is he like terms with that? No, they don't have the same number of variables. He has no variables. Yes, sir.
Then how come there's 4 up there if those 2 in the middle are the same, the one on the left's different, and the one on the right's different?
I'm not done yet. Right now there are 4 terms. How many of those terms are like terms? The 2 in the middle. Once I put them together, how many like terms? I mean, how many terms will there be? There'll be 3. Yeah. So right now there's 4. So I love the way you're thinking. You're like, dude, you put the middle. You got 3. But right now there's 4.
Right.
What do I get when I put these together? 2 of these minus 4 of these.
No, what? Say that again?
Negative 4.
If I got 2 of these
Yeah.
minus 4 of these.
You got -2.
Yeah. What's 2 minus 4? Negative 2. So I get negative 2 what's? X squares. So if I had 2x squares and I take 4x squares away, I got negative 2x squares left. Yes, sir.
I don't understand.
So we have to remember, we have to be able to do this kind of thing without much trouble. We desperately need to get a rule down that will help us through that, because now we're going to start adding stuff on top of that. So 2 minus 4 is what?
2.
Negative 2.
4 minus 2 is 2. 2 minus 4 is negative 2. The bigger one is negative. So I know the answer is going to come out negative. So this is negative 2. So what's 2x minus 4x? Negative 2x. What's 2x squared minus 4x squared?
4.
Negative 2x squared.
So when you bring down the 8x, what happens to the plus?
Oh, no, so I've got, be careful. What can I say this? We've done, let me finish this problem out real quick. And to finish it out, I just have to put the plus 6 back there, and I'm done. I combine my like terms, I'm done. So now how many terms do I have in the answer? 3. I like it. So to answer your question, we've done problems like this. Somebody help me out. There's no variables in there at all. If you feel a little bit more comfortable with this one, how do I do this problem?
We should like use a negative 2 by 3.
I like it. So you got to do the exponent first. What's negative 2 cubed? Not negative 6. Good. It's negative 2 times negative 2 times negative 2. So it's 5 plus negative 8. What's a way to rewrite this?
8.
Negative.
Yeah, it's 5 minus 8.
8.
Where'd the plus go? It's not really a question, really. It's just the plus and negative is minus. So here, this is 8x plus negative 2x squared. So I could write it, let me see.
But on the bottom one, there's no multiplication, and on the top one, there is.
Well, I could put in there, right? It would still be the same idea, because when you figure out what your like terms are, you can almost forget about them for a second and just focus on your numbers. So if I have 5x minus 7x, I know it's going to be x. Now I can focus on 5 minus 7 is negative 2. So 5x minus 7x is negative 2x. I can just focus on the numbers once I figure out their like terms. Here, I have 8x plus, what did we figure out these two were? 2 minus 4, negative 2x squared. So the plus didn't go anywhere. It's just a better way to write plus and negative is just straight up minus, right? Adding a negative is the same thing as subtracting. If I add debt to you, I've taken some of your money away, right? We've talked about that before. Plus and negative, another way to write that is minus. Okay, so you got to realize that math has better ways of writing adding a negative. There's multiple signs in a row. Math doesn't really like that. You could write it that way if it's easier, but in general, math doesn't like that. It doesn't want to write 8x plus a negative. It's much better just to get right to the point. That's 8x minus. Adding a negative is the same thing as subtracting. It's just another way to write that same thing, just more concisely.
Can you put a 1 right next to that plus and then do the problem?
You mean like right here? Sure. This is 1 times this. Okay. And then what happens?
You have negative 2x2 per square.
Okay. All right.
But that doesn't really change it, just a different way of getting the same thing.
Okay. If that works, cool. All right. So, you get the feel for like terms. Yes, sir.
You don't get it.
Which part?
Still.
So, here we go. When I give you a problem, like this here, let me give you one that's a little more interesting. Okay, that's gross. Now, I try to teach people, you could actually rewrite this problem and move stuff around to be next to each other, but let me show you what I normally do. The first step is to identify what your like terms are. The first step really is tell yourself what you could do something with. So what's anything like terms with this dude? Who's like terms with him?
1, so 2.
Careful. I'm not asking for an answer. I'm asking for what other term in here is like terms with this. This is 6 ABs.
7.
That's like term. Those two are like terms.
1.
They will be eventually, some kind of 1. Maybe, because that guy's bigger, it's going to be... We'll get down to the next step.
But
Anybody like terms with him? Oh, sorry.
You keep the negative with it, right?
Definitely.
Okay.
Yes. That is a negative 7AB. So if I did move him, I could move him here. It still has to be a negative 7AB. Because that's what that is. But I'd rather not move stuff. I just have to identify what like terms are. Anybody like terms with him?
Yeah.
4B.
Good. So 7B, 4B, like terms. You see what I'm doing? I'm just using different symbols to kind of underline them. So visually I can pick out very quickly what my like terms are without having to rewrite the whole problem. Anybody like terms with him?
Nope.
Nice all one.
1.
So now I get 6 of these minus 7 of these.
0.
6 of these minus 7. Negative 1 AB. You don't need the 1 there really, but I can put it there for now. So I put those together.
Can you have negative AB?
Sure, of course. Right, that doesn't mean the same thing. But if you leave it like that, I'm cool with it. You can have it there or not. I don't care. What about here? It's negative 7B plus 4B.
3B.
What kind of 3B?
Minus.
Negative. And then this guy, you just write that up there.
And that's how we solve that question?
That's how you simplify that expression. Yes. The word solve only works with what kind of things? Equations. I can solve an equation. I can simplify an expression.
So if
And
you're
simplify really just means do the operations.
So I've been doing way too much, huh?
Could be. If you're actually getting an answer, like a number answer for something, for this, no.
Well, maybe not for that, but okay. So my if that says simplified that had that
Yeah,
underneath it, whatever
that's where you
call
would
that,
stop.
That's where I would stop. But
Exactly.
if you said simplify like terms, I would do that.
Yeah, I might not say like terms, be careful.
What would you say?
I would just say simplify.
Okay.
And that means do as much as you can do, which brings in the idea of like terms. Because I'm adding and subtracting, I can only add and subtract
So
like
it doesn't
terms.
matter where the like term is. If that
Doesn't
was like
matter.
15 things long,
Exactly.
I just pick out the like terms and
Because
stack
real quick,
each other.
I'm done with this, right? That's it.
Yeah.
It's boxed off. It must be done in just 1 second. I could have done this problem like this. I could have said, move this here. Then here's my minus 7b, right? You guys see, I moved that there, see?
Uh-huh.
Then there's my minus 7b. I can move that 4b there. And then this dude is at the end because he's all by himself. That's another way to do this problem. But you can see two things it's more time to rewrite it. You don't really need to. And very often people, it was a really good question, which actually, I want you to understand why it works this way. This negative is with this. That 7AB is negative. So if I move it, it's got to still be minus 7AB. It's not this stays here. It's that is negative, so it goes with it. You guys see the difference there? But I'm trying to tell you, you don't have to move things unless it's easier for you. You can actually just kind of identify what's like and then put them together.
Are you putting them together so they can cancel out? That's why you put them side by side?
So that now it's like right together with each other. But it's not that big of an advantage than just looking at that, is it? Now, if it's easier for you to look at it like this, feel free, please, dear God. You can move stuff around. You can do a problem almost any way you want to, as long as I can tell what you're doing. But I'm just trying to tell you, you don't need to waste time rewriting the whole problem. You can actually just identify your like terms using different underlinings and then attack it. You don't have to rewrite the whole problem. Yeah, so it's the same problem, right?
1.
6 minus 7 is negative 1.
Negative 1.
AB.
Then make that be negative 3.
Yeah.
The,
And this guy's by himself. So he just stays the same.
That's 5 times 2 is 20.
No, it doesn't say 5. It doesn't say. Now be really careful. I like that you said that. Because that is a common mistake. When I write this, sometimes I'll have people tell me that that's that.
5.
Now what mistake did I do?
The 2's for the x.
Yeah, what's being squared? Not the 5. What's being squared? What's being squared?
1.
What's the square sitting on?
1.
Yes. So this means 5 times x, right? Not 2 5s. So be real careful. That square can't jump over here. Just because you don't want x squared somewhere, too bad.
So just put x.
If you needed to, but normally that would just be that's by itself. That's fine. You don't have to break it out. Yeah.
For example 5, you wouldn't have to solve the problem, just simplify it?
Again, do I know what A and B are? No. Do I have some condition that would help me? Now, some of you guys might be thinking, we don't know what you got, Jeff. We don't know your medical history. No, I don't mean that. I mean, what I mean by a condition is, if I just write x minus 7, that doesn't become 7x or something crazy. Can I put those together? I can't solve that. What's x supposed to be? Why can I not solve it? Because I don't know what the answer is supposed to be. If I told you this is supposed to equal 0, then I can say x has to be what?
0.
I love it. It has to be 7. Because if to solve this, you say plus 7, plus 7. But I couldn't do this unless I had 2 sides. And I can only have 2 sides if I have an equal sign. So you cannot solve unless you have that equal sign. That gives you a condition that you can then use. If it must equal something, then x can only be one thing to make that work. That's why I can solve equations. Yes, ma'am.
So when you have negative 1, AB, and AB by itself means 1, so to speak,
Yes.
that always throws me off and makes me feel like there's an extra number left over. Like
So-
1 is what's left over from the numbers, not the representation of AB.
Well, it's just because of the fact that
So how can that negative 1 just disappear?
it doesn't
negative
disappear. It's what's 4AB minus 1AB? 3AB, right? All right. What's 4AB minus AB? 3AB, because I know that this means how many?
1.
See, I know it means 1. I don't need the number 1 there. I can see that there's only one of them.
But I'm saying that negative 1 didn't come from AB, it came from the 6.
No, but what you don't get is that this is telling me how many ABs I've got.
Oh, okay.
So I don't care where it came from. Right now it tells me I have 1 AB. It happens to be negative. So I do not need that 1 because I know AB by itself means one of them. Good. How are we doing? Yes, sir.
So B, 3, huh?
Where are we looking? Sorry.
The bottom, B, 3, right?
Where?
B,
Oh, here?
No, the purple thing, that with the square.
Your answer.
Answer.
Here? Here.
Yeah.
Okay.
B, 3, right?
I'm not sure what you mean
He
BB3.
doesn't see the A. AB.
AB?
Yeah. He thinks it's BBB. Instead of.
3A. B, 3.
Oh no, this is 1AB. It's not BBB. Yeah.
It's different.
There's no.
2.
So to get 3B, I'd have to have B plus B plus B. That's how I get 3B.
I don't understand.
That's okay. You can come see me in my office. We can do more of these.
They have to be exactly the same.
They have to be, exactly. So you can't say like 7xz minus 2wz and just say, oh, they both have z's. Yay. Right? Can I do anything with those? No, I have to leave that on. If I said simplify that, you're completely allowed to say, I'm done. Because you can't do anything with that. Just because they both have a z doesn't mean anything. This is 7xz's. This is 2wz's. I can't put those together. They're not the same thing. What could I put together? 7xz minus 2xz. They have to be exactly the same in order for me to put them together. 7 of these minus 2 of these is, what's 7 something minus 2 something? If I had 7 shoes minus 2 shoes, how many shoes would I have?
1 shoe.
If I had 7 minus 2. 5. So 7 of these minus 2 of these is 5 of these. Okay. So the next kind of thing we need to be able to do more complicated is the distributive property. I think I've talked a little bit about this before. I think I even showed you why it works. But the basic idea behind this is it's sort of, let me see, let me make this through. It sort of feels like cheating at first. Because order operations would tell me, what do I have to do first here in this problem? I want to simplify this? No, what would order operations say? I'd have to do in the parentheses first, right? So can you tell me what x plus 5 is?
5.
5 is 6.
I'm glad you said that. X plus 5 is definitely not 5x. Because what operation is this? Addition. What operation is this? Multiplication. So if I make x2, I get 7 here, if I get 10 there. They are not the same thing. So be really careful. You can't make addition become multiplication. I like it. So you guys know the property, but you know why it works. Because it's going against order operations. Right? And I gave you 2 ways to do it. Please just keep out here on Sally, my dumbass son, and we went over the order operations, and this is very important, and then suddenly now we're going to break it. We're not really. Because, remind me, what's 3x really mean? Don't tell me 3 times x. What's 3x really mean? X plus x plus x. Right? 3 something is something plus something plus something. So what's 3 this? This plus this plus this. All right, let me let you absorb that for a second. If 3 this is this plus this plus this, then 3 this is this plus this plus this. It's the same, it's got to be the same thing. 3 followed by anything means that thing added to itself 3 times. Cool. And then what can I do now? Now I don't have multiplication. I have only addition. So I can do that whatever order I want to. So x plus x plus x, 3x, 5 plus 5 plus 5. So never do that, please, dear God. That shows you why it works. But I heard a few of you guys already know the shortcut. Distributive property actually makes a lot of sense because you distribute the 3. You got 3 x's and 3 5's. So, for another example, real quick.
Well, wouldn't the x count as 1x?
Of course, sure. And what's 3 times 1?
3.
So it becomes 3x. You with me? Okay. But no, it's, please. I mean, ask any question you want to, because I want I don't want you to feel like you should be quiet about any problem you have with anything. You shouldn't just accept it because the teacher said so. You should be like, why the hell does it work? Maybe all your math is crap, right? It's possible. Maybe we made a whole system of stuff that doesn't make any sense. So ask the question. Make sure you know why it works that way.
So you can put the x next to the 3 because you're multiplying by x?
I love it. That's what that represents. I'm multiplying 3 and x.
Alright, so you wouldn't do parentheses first, as in 1x plus 5 equals...
But are they like terms?
Oh, you're right.
They're not like terms. If it was x plus 5x, hell yes, I would do that. Right? Yes, sir.
Would 3 times 5 is 15?
Say again?
3 times 5 is 15?
I love it. So 3 times x is...
5.
What's 3 times x? 3x.
3x.
Plus 3 times 5? 15. So that's, you just distribute that number to both. Kicks ass. Let's do another one. What about...
Oh, 8x minus 12y plus 20.
Could be.
5.
So you take that 4. That 4 is multiplying by this whole thing. So you multiply by this piece, and what do you get? 8x minus 12y. I love it. Plus 20. I love it. Right? So it's a shortcut. Distributive property. Mathematicians actually named something that made sense. Yeah.
That'd be 8, right?
I can't do anything further with this because is it equal to something? No. So it's not an equation. I can't solve it. I don't know what x and y are. And are there any like terms? There's no x's to go with him. There's no y's to go with him. There's no numbers to go with him. So I'm done. There's no like terms. So I know in a few of these problems it's not going to feel right. You're going to be like, I can't be done. I didn't do a lot. Right? Math is not about doing a lot. Math is about doing exactly what they ask you to do, which sometimes is a lot and sometimes is barely anything. Yes, sir?
So we're doing it with distributive property deal the way you're drawing the lines over because we don't know what x or y is. So that therefore we cannot do the parentheses first.
I love it.
So we're just cheating.
That's not cheating. I really want you guys to understand. I've rewritten the problem in a different way that's completely allowed because it's the definition of what 3 times something means. What does 3 times something mean? I got 3 of those things adding. That's what it means. 3 times 2 is 6 because 2 plus 2 plus 2 is 6. You with me? So what's 3 times this? This plus this plus this. And then I have nothing but addition. I'm allowed to add whatever order I want to. Now, real quick, since you asked that question, let's do this one 2 different ways. Let's do it the first way. Let's do it pure order operations.
Minus 3.
Yeah, I have to do in here first. I love it. Negative 12. So any other damn way I do that problem, I better get freaking negative 12 or that other way needs to be thrown out. So if I do distributive property, what do I get? 8.
Negative 20.
Good, minus 20. You guys, let me make sure you guys are with me. Just distribute that. 4 times 2 is 8. 4 times negative 5.
Okay, but we can do the first one. 4 and negative 3.
Where am I at? Oh, sorry. So this is 2 totally separate ways to do this problem, right? One way to do this problem is do the inside first. That's where I got negative 3.
Okay.
And then 4 times negative 3 is negative 12. Now let me start over. Let me do this problem a different way. If I do a distributive property. You guys with me what I'm doing here? I'm doing the same problem twice.
Right.
These have nothing to do with each other, except they better have the same freaking answer, right? And what's 8 minus 20?
Negative 12.
Negative 12. Sweet.
What?
Yes.
But. So what is this?
So I have 5 times z plus 4w. And you at this point, just accept that the variables represent numbers I don't know yet. That doesn't mean I can't do anything with them. I can do certain things with stuff I don't know. If over there I got 3 things I don't know, and over there I got 2 things I don't know, I'm surrounded by 5 freaking things I don't know. I can still combine them. I can say, I got 5 things I don't know. I don't know. Right? I can still do something with them. Here, what I can do, I got 5 of these freaking things. Right? And I can't do the inside. I can't do order operation. So I have to do the alternative way. Which is, what am I doing with the 5? 5 what this? Times. So 5 times z.
30.
No, it's not 5 times 6. It's 5 times z. 5 times z. 5 times z. That's 5 times z, right? When you see a number sitting next to a letter, that means multiplication.
Yeah.
Now what's 5 times 4w? 20w.
That's 12.
Done. That's simplified. I will. Because that's the right thing to do. Alright, yes sir.
So it's 20 minus 12 is 8.
There's in this problem, I don't know what z is, I don't know what w is, I can't do anything further. Are these like terms?
Yeah.
I got 5 z's and 20 w's. I can't combine them.
One term.
I like it. There's 2 terms, but they're not like terms. Now, if it was 5z plus 20z, what would that be? 5z's plus 20z's is. If I got 5z's and I got another 20z's, how many z's total do I have? 25 z's. Right? 5z's plus 20 z's is 25 z's. So really it's just like 5 chairs plus 20 chairs is 25 chairs. That z is just something I don't know yet. 5 closed boxes, because I don't know what the hell it is, plus another 20 closed boxes, there's 25 freaking closed boxes. Right?
So that the z is for having 5s, right?
That z is something I don't know yet. I don't know what number that z is. But I can collect them. So if I had a bunch of z's just laying around, z plus z plus z plus z plus z, I can collect them together, right? I get 1, 2, 3, 4 z's. So if I added another 7 z's,
That's 11 z's.
that's 11 z's. Kick ass. You got it. Perfect. Hold on to that, because that's exactly how you do that. Don't forget that. All right. Whew. By the way, next class is going to be, thank God, I am not going to be talking as much. I'm going to be letting you guys work on some stuff from the Blue Book. But I just need to lay the groundwork for what the hell we're going to be working on, right? So I don't know if you guys are all like, God, this guy talks a lot. Okay. All right, so here's where this is leading us. Let me take it to the next level, and then we're going to bring it back into play with equations. And by that time, it'll probably be time to leave. Let's not use z. So, in this problem, can you see where there might be some like terms eventually?
Yeah.
Right, there's w's and y's. The reason I can't just put them together, I cannot just say w minus 2w, because all my variables are stuck. They're trapped inside. You guys, does that make sense if I say that? So, before I can start combining like terms, I have to free everybody up. And the way we do that is distributed property. If only that stupid 4 and that stupid 5 wasn't there, I can put my like terms together, right? Right? If that wasn't there and that wasn't there, I could just start adding like terms, right? If these stupid parentheses were there. So how do I kill them? I just distribute it. Then I'll have a bunch of free terms, free pieces that can go together. Right now, I can't put that w with that set of w's because it's stuck inside here. Can I add before I multiply? No. Right? I have to multiply this first, and then I can start adding my like terms together. So I like the idea. I don't know if you guys like it too. This is all stuck inside the 4 outside. So if I distribute the 4, they're separate. They're free pieces. So what do I get when I distribute that 4? 4w. Good. 4 times negative 2 is negative 8. Cool.
plus 21.
Good. 5 times 4 is 20.
Minus
Y. Good. 5 times negative 2 is negative 10. W. And now you identify your like terms?
You don't have to carry the parentheses down there.
What was the only reason, I like that question, what was the only reason those parentheses were really there? To signify what? Multiplication. We did the multiplication so they're not needed anymore. We actually multiplied by 4, didn't we? So the only reason these parentheses are here is to show that it's this times that. So once you do that, you don't need it anymore. It's sort of like 6 times 8. What's that? 48. Where do the parentheses go? I don't need it anymore. I just did the multiplication. I don't need them anymore. You kind of with me?
Oh, yeah.
Okay, good. Yeah.
Wait, okay, I think I get it now. Because 4 times 2 is 8.
You see it?
4 times 5 is 20. Then
5 times 2?
5 times 2 is 10.
Good. And be careful with the negatives, right? You got it. And the variables just, 4 times W is 4W.
Yeah,
Variables just stay right where they are.
that's 1.
So what are your like terms? What's like with this guy?
1.
The 10 W's. And what's like with this guy? 20. So what's 4 W's minus 10 W's? Good. Negative 6 W's. And what's negative 8 Y's plus 20 Y's? Careful, the bigger one is positive. So plus 12 Y. So it's really, I think you can notice, if you still have trouble with problems like 5 minus 12 or something like that, you desperately have to get that down now, because we're going to start doing stuff that builds on that. And if you have a problem with that, you're going to be really behind on this stuff. You need to get that by itself locked down. You don't want that to be the problem here. Yeah.
Okay, but wait, so the big number.
So when I have two numbers that are different signs, the bigger number tells me what the answer is sign going to be. 20 minus 8 is 12.
Yeah.
And the bigger number is positive, so it's positive.
Where'd you get that negative 6 again?
Because 4 minus 10, different signs, 10 minus 4 is 6, but the bigger one is negative. I like it. So those rules will take you through all those kind of things. Alright. So here's the connection with equations. So let's do this. Now that we kind of know distributive property, we kind of get a feel for like terms. We can do problems like this, for example.